Agri-Food is responsible for 21 to 37% of all the global greenhouse gas emissions. At Lincoln, we're trying to develop a whole new series of technologies to deal with those emissions. We're focusing on developing lightweight robotic vehicles powered by renewable energy instead of fossil fuel, machines which can wander around fields, identify pests and diseases, deal with them in real time, but without using synthetic pesticides. And we're using AI to help farmers make better decisions, reduce food waste, which will hopefully make a significant contribution to reducing the impact of the agri-food system on our climate.
So I specialize in long-term autonomy. That means making robots move on their own. We're doing this in lots of challenging environments, particularly also outdoors, and we're here at Rice Home, which is our little strawberry farm where we try out these robots. But one of the big problems we're trying to solve here is the problem of food waste. Farmers need very accurate predictions of when the fruit is ripe, when it should be harvested, and when they want to get it into the market. We can use machine learning techniques, AI, and robotics to make better predictions so that we cut food waste and therefore have a positive impact on the carbon reduction. The big vision here is, of course, that we move towards a fully automated soft food production. That means replacing, in that sense, carbon-intensive workflows that you may have at a farm, all with electrical vehicles that can just operate on their own.
The current ways of producing food rely on wide-scale application of pesticides. This approach, however, is unsustainable due to unprecedented pressures. Our team is working on robotic technology that does not rely on spraying chemicals. Our computer vision systems are able to identify individual weeds, and the robot is able to eradicate individual plants, whilst our navigation system is controlling the robot carrying UV light, which is destroying powdery mildew in strawberry plants. Currently, we are working on improving that technology so that it can work with any type of disease in different crops and in different fields.
One of the projects we're looking at here is on biofuels, which are an alternative to fossil fuels like gas and coal. And these are just plants that we burn for electricity. We want a lot from these plants, so we don't want them to use a lot of inputs because those inputs themselves take a lot of fossil fuels to produce. And we don't want them to displace food, so we want them to grow on marginal land, and we want them to be very space efficient, so produce a lot of biomass in a small area. A really good candidate species for this is Miscanthus. It's a big tall grass that produces a lot of biomass in a small area, and the project will be looking at how to help that establish and grow more in the UK.
Phenotyping is a technique that analyzes sensor data such as camera images and recognizes traits that characterize individual plants. This is a very difficult task, especially if you're trying to determine actions to be performed in real time. We are developing state-of-the-art machine learning techniques to solve this problem, particularly focusing on methods that will perform quickly and accurately in the field. Limited image analysis can be conducted on a robot in the field. However, we are looking at more sophisticated methods that offload some of that processing to faster, more powerful computers in the cloud in order to perform more accurate image analysis.
One of the things we're doing at the university is looking at carbon monitoring throughout the agricultural system and the arable crop production. It's really important for giving soil some really good, healthy, beneficial properties. It can be a habitat for biodiversity, it can help with flood resilience, and it's also great for crop growth itself and providing a nice environment in the soil for roots to exploit. One of the things we don't fully understand yet is the role of different crops in carbon dynamics, in taking up carbon from the atmosphere. So what we're trying to do here is use a flux tower to monitor carbon fluxes from a crop, and as we move into perhaps more novel crops, we're going to get a detailed assessment of the actual carbon budget of those crops.